This video goes over the third method of solving, which is when you can't factor a quadratic equation. So if you remember, we've got three possibilities for solution. Two solutions, one solution, or zero solutions here. So just as a warm-up, we're going to solve this. So first one, we're going to solve by factoring 3, 1, 1, 3, 1, 2. So we've got 6 and 1. That's going to be my option that works. I've got x plus 6, x minus, and it multiplies to 2. Got a little bit carried away there. Whoopsie daisy. So let's try again. 3, 1, 1, 3, 1 and 2. So we've got 6 and 1. Oh yeah, I was on the right track there. Okay, positive 6, negative 1. So we've got 3x minus 1 and x plus 2, which is going to tell me that x equals 1/3, x equals minus 2. Now I'm going to do my second one, start off by moving it over, and then I'm going to notice that I can't factor. And this happens sometimes. When you're solving, the numbers don't work out nicely. So this is our next strategy that we can use, which is the quadratic formula. And the roots of the quadratic equation, ax squared plus bx plus c equals 0, are given by the quadratic formula. You don't need to memorize it. It is on your formula sheet, but it is here. Probably you will have it memorized. There is a song that goes with it. X equals negative b plus or minus a square root b squared minus 4ac all over 2a. So we've got two roots. We've got the positive root and the negative root. If you remember, we talked about the discriminant. Here it is, underneath the square root. That is how you can tell how many solutions you are going to have. Because if your number underneath the square root is positive, you're going to have two solutions, because you can take the square root. If your number underneath the square root is 0, you're only going to have one solution, because the square root of 0 is just 0. If it is less than 0, that means you've got a negative number underneath the square root, and so you can't take the square root, so you don't have any real solutions. Let's look at some examples here. So here we're going to look at 5x squared minus 3x minus 1. So our a value is 5, b value is minus 3, c value is minus 1. Solving for x using the quadratic formula. So I'll write it again up here. So we have it on our page. I don't need to see you write down the formula each time, but you should show me the numbers that you are substituting in. 5 and minus 1. And then, what do we have here? 2 times a. So then what I'm going to do is simplify underneath the square root. So 9 plus 20. So I've got root 29 over 10. Now, if you leave it in this form right here, okay, then these would be the exact roots. If you want to go further and put it into decimal form, we can just evaluate it. So 3 plus root 29 divided by 10, we'll write down as our first one, which is 0.839 approximately. And then our second one is going to be 3 minus root 29 divided by 10, which is going to give us minus 0.239 approximately. Here we go. Let's do another example. This time we've got y, but it still works the same way. So our a value is 1, b value is minus 6, c value is 13. This time we're solving for y. So we're going to put the y on our left side, and then we're going to make our substitutions into the quadratic formula. So we've got negative b plus or minus square root b squared minus 4ac all over 2a. So simplifying underneath the square root, I've got 36 minus 4 times 13, which is going to give me minus 16 over 2. Right here causes a problem. I can't do that. So I've got no solution when you have a negative underneath the square root. Okay, let's do another example here. I've got m this time. My a value is 2, b value is 7, c value is minus 3. And I'm solving for m. So I've got negative b plus or minus square root b squared minus 4ac all over 2a. So I've got 49 plus 24 is going to be minus 7 plus or minus root 73 over 4. I can leave that as is, or I can evaluate it to find the decimals. So I've got minus 7 plus root 73 divided by 4 would be my first answer, which is approximately 0.386. And then my second answer here is going to be minus 7 minus root 73 divided by 4. Let's try that again. Minus 7 minus root 73 divided by 4 is going to give me approximately minus 3.89. Okay. Another example here, a equals 2, b equals 5, c equals minus 3. X is going to equal negative b plus or minus square root b squared minus 4ac all over 2a. Simplifying underneath the square root is going to give me 25 plus 24, so root 49 over 4. Root 49 is a nice number, so I've got 5 plus or minus 7 over 4, which gives me my first answer as a half, and then my second answer as minus 3. So all this tells me that they worked out nicely, is that I could have factored. Now the quadratic formula always works. It's not always the most efficient, but if you're looking at a tricky trinomial or a simple one with some really big numbers and you can't see the factors within the first sort of 30 seconds, you can always go to the quadratic formula because it will always just spit out nice numbers if you could have factored it. Okay. Last example that we're going to do here starts off as not in standard form of the quadratic equation. So we're going to have to expand and move everything over onto the left-hand side. So 5z squared plus 10z minus z minus 2 minus 6z minus 3, and then minus 7. I'm just going to move that over. So I've got 5z squared, then I've got 10z minus z, 9z, minus 6z would be 3z. And then I've got minus 2 minus 3 minus 7. It's going to be minus 12 equals 0. So now I can use the quadratic formula with my a value is 5, b value is 3, c value is minus 12. And I've got z equals negative b plus or minus square root b squared minus 4ac all over 2a. So z here is going to equal, let's see, minus 3 plus or minus 9 plus 20 times 12. What a big number. Okay, 240. So I've got root 249 over 10. And then what I can do here is put that into decimals. So I've got minus 3 plus root 249 divided by 10 gives me approximately 1.28. And then my other one is minus 3 minus root 249. And I'm going to divide by 10. So here I get approximately minus 1.88. Another tool in your toolbox for solving quadratic equations.